In the vast, ink-black expanse of the northern sky, there's a star that seems to defy the ceaseless motion of the cosmos. It stands still, a silent sentinel amidst a swirling dance of galaxies and nebula. For millennia, this steadfast beacon, Polaris, has guided sailors across treacherous, featureless seas and explorers into the vast unknown of uncharted lands. But herein lies a beautiful and profound paradox. This familiar celestial friend, a constant in the story of humanity, is one of modern science's most bewildering and captivating puzzles. To our naked eye, it shines with a proud, unwavering brilliance, a pinprick of serene light against the chaos of the night. Yet, when viewed through the powerful lenses of modern telescopes, it reveals a nature far from simple. Every measurement we attempt to take seems to contradict the last, throwing our data into disarray and challenging the very foundations of the cosmological models we have painstakingly built. What profound secrets is Polaris, the North Star, hiding in plain sight? And why does it seem to delight in confounding us? Join me on a deeper journey to rediscover this star, one we think we know intimately, but which holds mysteries complex enough to shake our fundamental understanding of the universe itself. We will venture beyond its light and into the very heart of its enigma. A beacon through history, humanity's lighthouse. Long before humanity conceived of maps or magnetic compasses, the night sky was our first and most trusted guidebook. It was a canvas of myths, a clock, and a calendar all in one. And among the countless twinkling lights, each with its own story, one star remained almost perfectly, reassuringly fixed: Polaris. Situated nearly in a direct line with the Earth's rotational axis, it holds its position with stoic grace while all other stars appear to perform a grand circular promenade around it throughout the night. This singular stillness made Polaris the eternal lighthouse of the Northern Hemisphere, a celestial anchor in a sea of change. Ancient Egyptians, masters of engineering and astronomy, used it to align their pyramids with cardinal precision and to navigate the life-giving Nile. The seafaring Greeks and Romans, who built empires on maritime trade, relied on its constant presence to cross the unpredictable Mediterranean Sea. Even Arab merchants, undertaking perilous treks across the shifting sands of immense deserts, knew they were on the right path with just a glance toward the North Star. In the East, its cultural significance was just as profound. Chinese dynasties, with their sophisticated understanding of celestial mechanics, used its position to calculate the seasons, create elaborate star maps, and saw it as a divine symbol of imperial power. The unmoving emperor in a celestial court around which everything else dutifully revolved. Finding Polaris by eye, however, has always been a simple trick of celestial geometry, often involving its famous neighbor, the Big Dipper, Ursa Major. The two stars forming the outer edge of the Dipper's ladle, Merak and Dubhe, act as a perfect celestial arrow. Follow that imaginary line upward from the ladle, and it points directly to a bright, solitary star that seems to wait patiently. That is Polaris. This simple, elegant method has been passed down through countless generations, from Greek sailors charting new trade routes to medieval European explorers dreaming of new worlds. Imagine for a moment a world without the North Star. Would those early, courageous oceanic voyages have ever been attempted? Would humanity have dared to leave the safety of the coast for the dark, intimidating vastness of the open sea without a single, reliable point of reference? Without its unwavering guidance, the entire history of trade, exploration, cultural exchange, and perhaps civilization itself might have unfolded in a completely different, more isolated way. Polaris is so much more than a star. It is humanity's first compass, an embodiment of our innate desire to find our way in the darkness. And it's from this seemingly simple, practical role that a far more complex and mysterious truth begins to emerge. The first surprise: Polaris is not alone. For thousands of years, we looked up at the North Star as a symbol of solitude and constancy, believing it was a single, solitary point of light. The invention of the telescope, however, shattered that simple picture forever. The star we thought was a celestial loner turned out to be a complex, gravitationally bound triple star system, a hidden cosmic family whose intricate dance was invisible to us for most of history. The first hint came in 1779, when the keen-eyed astronomer William Herschel peered through his telescope and observed a much fainter, smaller companion star nestled beside the brilliant primary. This discovery, named Polaris B, immediately shook the long-held belief of a single North Star. But the mystery deepened. Over a century later, astronomers studying the spectrum of light from the main star noticed unusual shifts, a telltale wobble in its velocity, suggesting an unseen partner was tugging on it with its gravity. This ghost remained invisible for decades. It wasn't until 2006, with the unparalleled power of the Hubble Space Telescope, that we finally captured the first direct image of this third member, Polaris A, a dwarf star orbiting incredibly close to its giant sibling. So what we see as the single North Star is actually the overwhelming light from the main star, Polaris A, a colossal yellow supergiant more than 5 times the mass and thousands of times the brightness of our Sun. Orbiting it in a tight 29-year-long embrace is the tiny Polaris AB. And much, much farther out, like a distant cousin, Polaris B slowly circles the central pair in a massive, leisurely orbit that takes tens of thousands of years to complete. This revelation changed everything. It was a profound lesson that the universe is often more complex than it appears, forcing us to reconsider how we view the stars. Perhaps other seemingly simple lights in the sky are also hiding complex stories. Polaris was no longer just a guide. It was proof that the closer we look, the more profound the secrets the universe reveals. The cosmic yardstick, a fickle standard candle. In the early 20th century, at the Harvard College Observatory, an astronomer named Henrietta Leavitt made a discovery that would forever change our map of the universe. While studying photographic plates of the Magellanic Clouds, she found that a special class of stars, called Cepheid variables, pulsate with an astonishingly predictable rhythm. But crucially, she realized that a star's intrinsic brightness, its true luminosity, was directly linked to the length of its pulsation cycle. The brighter the star, the longer it took to pulse. This was like finding a key to unlock the universe's vast distances. By measuring a Cephid's pulse, we could determine its true brightness. By comparing that to how bright it appears from Earth, we could calculate its distance with remarkable accuracy. Cephids became our standard candles, cosmic lighthouses that allowed us to measure distances not in thousands, but in millions of light years. And for the first time, to truly map the cosmos and understand its scale. And as cosmic fate would have it, our North Star, Polaris A, is the closest Cepheid variable to Earth. This unique proximity should make it the gold standard, the ultimate calibration point for our entire cosmic distance scale. But here's the problem that keeps astronomers up at night. Polaris doesn't behave. Its pulsation cycle isn't stable. Its brightness fluctuates unpredictably, defying the very consistency that makes Cepheids useful. If our most important, closest standard candle is unreliable, how accurate can our measurements of the rest of the universe be? It casts a shadow of doubt over our calculations for everything from the distance to nearby galaxies to the expansion rate and ultimate age of the universe itself. The familiar star on the horizon had suddenly become a question mark, challenging the very tools we use to understand our place in the cosmos. The mystery of a misbehaving star. While most Cepheids follow a steady, metronomic rhythm, Polaris acts like a rebellious teenager, constantly changing its tune. From the 1960s, the amplitude of its pulsations, the difference between its brightest and dimmest points, steadily decreased for decades. Many astronomers wondered if it was ceasing to be a Cepheid altogether, settling into a quiet old age. Then, in the early 2000s, it unexpectedly reversed course and started brightening again, throwing all previous assumptions out the window. Its pulsation period is equally baffling. For over a century, its roughly 4-day cycle had been slowly lengthening by about 4.5 seconds each year, a gradual change that fit well with established models of stellar evolution. But since around 2010, the period has started to shorten again, completely contradicting the predictions of those same models. This erratic behavior has made Polaris a fascinating but deeply frustrating puzzle. What is causing this instability? One theory posits that we are witnessing Polaris as it passes through a very brief, chaotic phase of its evolution for the first time, a fleeting moment in a life spanning millions of years. Another suggests its strange behavior is a result of complex interactions with its close companion star, Polaris AB. Its stubborn refusal to follow the rules serves as a powerful reminder that our models are incomplete, and that even the most familiar celestial objects can hide secrets that stretch the limits of our imagination. The distance dilemma. Why is it so hard to measure? It sounds deeply ironic, but one of the brightest and most observed stars in our sky is also one of the most difficult to measure. When astronomers try to pin down its exact distance from Earth, a seemingly fundamental piece of information, the numbers become a frustrating mess. The primary method for measuring stellar distances, parallax, involves measuring the tiny apparent shift in a star's position as Earth orbits the Sun. However, Polaris is so intensely bright that it tends to overwhelm the sensitive electronic sensors of modern telescopes, saturating them with light and distorting the data. Furthermore, the gravitational pull of its two companion stars introduces additional wobbles and noise into the system, making the already minuscule parallax measurement incredibly difficult to isolate. As a result, estimates over the years have varied wildly, from around 323 light-years to over 520. Even powerful, dedicated space missions have failed to agree. The Hipparcos satellite, launched in 1989, suggested a distance of 434 light-years. The more advanced Gaia mission, with superior technology, has provided a figure closer to 447 light-years. A difference of a dozen light-years might not sound like much, but for a crucial Cepheid variable, that uncertainty is enormous. It throws off all subsequent calculations of its mass, radius, and true brightness, which in turn affects our entire calibration of the cosmic distance ladder. The star we can see most clearly remains one of science's biggest and most consequential measurement headaches. The age paradox. A young star with an old companion. Perhaps the most mind-bending puzzle of all is the glaring age difference within the Polaris system. According to the standard model of star formation, if all three stars were born from the same primordial cloud of gas and dust, they should be roughly the same age, like cosmic siblings. Yet, our measurements tell a different, seemingly impossible story. The main star, the supergiant Polaris A, appears to be a spry, youthful 50 million years old. Its distant companion, Polaris B, however, seems to be a much more ancient 2 billion years old. The age gap is not small. It's a chasm of nearly 1.95 billion years. It's like finding a teenager living with a great-great-grandparent and being told they were born on the same day. To resolve this paradox, one exciting and violent theory suggests Polaris A is a blue straggler, a star that looks younger than it really is because it experienced a cosmic rejuvenation. This can happen when two stars in a binary system merge in a cataclysmic collision, or when one star siphons vast amounts of hydrogen fuel from its companion. This infusion of new material essentially resets the star's evolutionary clock, causing it to burn hotter, brighter, and appear much younger than its true age. If this theory is correct, our North Star was once two separate stars that collided and merged, giving it a dramatic and violent new lease on life. This paradox isn't just a scientific curiosity. It's a powerful reminder that the sky is filled with incredible stories of death, life, and even stellar rebirth. A temporary king. The North Star won't be north forever. For all of recorded human history, Polaris has been our fixed point, our northern anchor. But its reign as the North Star is only temporary, a fleeting role in the grand sweep of cosmic time. The Earth's axis is not perfectly stable. It wobbles slowly like a spinning top, a phenomenon called precession. This wobble traces out a large circle in the sky over a 26,000-year cycle. This means the north celestial pole, the spot in the sky our axis points to, gradually changes. Around 14,000 years ago, during the time of our Stone Age ancestors, the brilliant star Vega in the constellation Lyra was the North Star. And in about 12,000 years from now, after the wobble completes its cycle, Vega will reclaim the title once more. Our beloved Polaris is just a placeholder in a grand cosmic timeline. The civilizations of the distant future will look up to a different northern sky, with Vega as their guidepost. This is a humbling realization that nothing in the universe, not even the pole star, is truly static or permanent. Even the stars we see as symbols of eternity are just temporary guardians in the endless, majestic flow of cosmic time. The enduring riddle. Polaris began its story in the human imagination as a simple lighthouse, a welcome symbol of constancy in a chaotic world. But the closer we look with the tools of science, the more it transforms into a profound and beautiful paradox. Its unpredictable light, its uncertain distance, its impossible age difference, and its temporary reign make the most familiar star in our sky one of the greatest unsolved mysteries we have ever encountered. Perhaps that is the true underlying beauty of the cosmos. It never gives us all the answers. It always leaves dark, intriguing corners for us to explore, to question, and to wonder about. Polaris, with all its magnificent and frustrating secrets, is both our guide across the oceans and our guide into the unknown frontiers of knowledge. It is a constant reminder that our understanding is small, and that the grand journey of discovery is truly, wonderfully infinite.